Hi everyone, I'm Miles. A POS company claims their new system averages 4 minutes or less. A sample of 36 customers had a mean of 4.35 minutes. Does this suggest the population mean exceeds 4 minutes? Is the difference real, or is it just from sampling randomness? Stats tests answer this. Null H0, M is 4. Alternative, M exceeds 4. With an alpha of 0.05, check if the standard deviation is known. If sigma is 1.2, use a one-sample z-test. The standard error is sigma over the root of n, or 0.2. Z is 4.35 minus 4 over 0.2, which is 1.75. With a p-value of 0.04, we reject the null. At 5%, we conclude the mean checkout time exceeds 4 minutes. The p-value isn't the probability the null hypothesis is true. It's the chance of getting a 4.35-minute result or more extreme, assuming a 4-minute mean, roughly 4.01%. If sigma is unknown and S is 1.2, use a one-sample t-test as estimating volatility adds uncertainty. With a standard error of 0.2, t is 1.75, df is 35, and the p-value is 0.0444. Since this is under 0.05, we reject H0. Though z and t are both 1.75, the t-test p-value is higher because the t-distribution's thicker tails reflect that extra uncertainty. For a known sigma, the 95% confidence interval is x bar plus or minus 1.96 times the standard error, giving 3.96 to 4.74 minutes. With unknown sigma, the t-critical value is 2.03, making the 95% interval 4.35 plus or minus 0.406, or 3.94 to 4.6 minutes. The t-interval is wider due to higher uncertainty. M equals 4 is within both 95% confidence intervals, yet both tests reject H0. The tests are one-tailed at alpha 0.05, while the intervals are two-tailed. A one-tailed alpha of 0.05 equals a 90% two-tailed interval. 4.01 falls outside this, consistent with rejecting H0. Finally, let's avoid a few common mistakes. A 95% confidence interval doesn't mean there's a 95% chance the true mean is inside, or that 95% of checkout times fall within it. Correctly, if you repeatedly sample, 95% of those intervals will contain the true mean. Also, failing to reject the null doesn't prove it's true, and statistical significance isn't the same as practical significance. Remember our framework. Determine if sigma is known, choose z or t, calculate standard error and test statistic, interpret the p-value, build the confidence interval, verify your confidence level and tail settings, then interpret the results to clarify the logic.